Okay, notice this one is a linear inequality. So for linear inequalities, you gotta follow your model of y equals mx plus b. Remember, we call this the slope intercept form. And hopefully by now we're used to moving things around. I got 4x plus y less than negative 5. So here, according to my model, my mx should be on my right side. So I need to move this 4x over here, right? So again, we use our properties of equality. Remember that each term, you name it by the letters, the variables, and the powers of the letters. So then these two are different families. In other words, the 4x is my mx, my negative 5 is my b. So I'm just going to write them side to side from each other. I bring this guy down, I bring this y down, and since it's a plus 1y, our goal usually is to reach that invisible 1. It's already there. We already finished, in other words. We don't have to divide or anything like that. So pretty much we're done. Remember that this number over here, my b, right, is our y-intercept. So that means we're starting at negative 5. And the number that's in front of the x is my m. My m stands for my slope. So my slope happens to be negative 4. And I'm going to make it negative 4 over 1 because we're supposed to have the rise over the run. Remember, that's the change in the y over the change in the x. The y goes up and down. Positive numbers are on top, negative numbers are on the bottom. So here you have a negative 4. That means the negative numbers are on the bottom, so you're going to be going 4 down. X goes left and right. Negatives to the left, positives to the right, correct? See, right there and right there. Then this is a positive 1, so I'm going to go 1 to the right. So starting from here, I'm going to go 4 down and 1 to the right. But notice that they didn't give us enough space to go 4 down. But you can always go in the opposite direction. If you already went 4 down and 1 to the right, I can go 4 up and 1 to the left. So I here go starting to move up from the starting point or my y-intercept, and I go 1, 2, 3, 4, and then 1 to the left. 1, 2, 3, 4, 1 to the left. 1, 2, 3, 4, right about here. My next question is going to be, okay, I got to look at my inequality right there. Guiding yourself from the y. In other words, if I think of this like a little Pac-Man or something, then my Pac-Man is going away from my y. In other words, the right side is bigger than the left side because in Pac-Man, we know that the more you eat, the better, right? The higher your score, so Pac-Man always wants more. So in other words, my right side is more than my left side, so if I guide myself by the y, then that means that my y is less. My y is less. So right here, when you have this symbol, this means y is less. So the other thing is, we have symbols that are like these, right? And those are broken lines. And we have symbols that are like these with an equal to in the bottom. That would be solid lines. So then that means that this is going to be a broken line. So when I graph the line itself, I'm going to need to make a dashed line or broken line, whatever you want to call it, because that means that it's not going to be including any points that are on the line. But it will include points that are less than. So again, the y-axis goes up if they're positive, or it goes down, right? On the bottom side here, I see the negative numbers. In other words, the numbers that go further and further up are greater and greater and greater. They're more and more and more. The numbers that go in the bottom, if you keep going down, then you're going less and less and less. So in this case, that means if y is less, then I need to shade to my left side, or shade down, because my left side would be down here in the bottom. I pick any point on my graph and I just shade down, just like the Y, shade down, and it just so happens that it's this side over here that's being shaded. That means that any point on this side would be a solution to my statement here. Okay?